Welcome to the unit circle, one of my favorite topics. The reason the unit circle is one of my favorites is because it's not about memorizing it, it's about understanding it. And to further understand it, we need to remember a couple things. So from geometry, remember your special right triangles. Look at these pictures right here. Remember how the short leg in a 30-60, if you double it, it's going to be the hypotenuse. If you multiply by root 3, it'll be the long leg. Here, they didn't use the variable x, but it's the same thing. So whatever the side is, you multiply by root 2 for a 45-45. By the way, these pictures are taken from the SAT. They are given on the SAT, not the ACT, but on the SAT, but you should know them. Some other things that are also written on the SAT that you should know is that the number of degrees in a circle is 360 and the number of radians is 2 pi. This is important when we're breaking down the unit circle and figuring out where all of the angles are. Here is a nice blank unit circle that we are going to fill out. We're going to focus on filling out the angles, the degrees and the radians. At the end of the video, I do have two different links. I have a link to a blank unit circle as well as a filled out one. So you can practice on your own. You can print off the filled out one to put in your notes, whatever you need to do. But right now, we're going to be looking at the degrees. So we know that there's 360 degrees in a unit circle, in any circle. So right here, we know that we start at 0 here, and that's also 360 because that's all the way around. So remember, half of 360 is 180, so that's where 180 degrees is. Half of 180 is 90. Half of 90 is 45, and that's where that is. So right now, I'm going to go around and fill out multiples of 45. So 45 and 90 are already filled out, plus another 45 is 135, plus another 45 is at that 180, plus another 45 is at 225, plus another 45 is at 270, plus one more 45 is at 315. And of course, if you add one more 45, you're back to 360. Fantastic. So these are all the multiples of 45. Now I'm going to go ahead and look at my first quadrant here, and that 90 degrees is broken in thirds. Well, a third of 90 is 30 degrees. Let's go up another 30 degrees to 60 degrees. Another 30 degrees is already at 90, so great, that's already filled out. Plus 30 degrees, we have 120. Plus 30 degrees is 150. Plus 30 degrees, 180. Already there. Plus 30 degrees, 210. Plus 30 degrees, 240, plus 30 degrees, 270. Yeah, I know, it gets monotonous, right? 270 plus 30, 300. 300 plus 30, 330. All right, so now the part that people are always like, I forgot how to do this part. Well, we're going to look at the radians, right? So if we think about 2 pi radians being in the whole entire circle, you have to think about breaking that up into parts just like we did the 360. So let's see here. Half of, I'm going to scooch this over for a second. So half of 2 pi is pi. So we know that 180 degrees is the same thing as pi. Half of pi is pi over 2. What do you know? Half of pi over 2, because it's half of a half, is pi over 4. So if you notice, we're doing the same thing. So now I'm going to go through with our pi over 4s and do the same thing we did with 45 degrees. So 45 degrees is 1 pi over 4. 90 degrees is 2 pi over 4. Wait a minute. 2 pi over 4 is the same thing as pi over 2. Well, that's right. So it's already written for us. So that was 2 pi over 4. Here we have 3 pi over 4. Here we have 4 pi over 4. Wait a minute, it's already written as pi. Yes, that's grand. Okay, so that was 4 pi over 4. Then we have 5 pi over 4, 6 pi over 4. I am going to make us simplify that because you know I like simplified fractions. So 3 pi over 2. Let's go ahead. And let's see, that's 6 pi over 4 and 7 pi over 4. And then we have 8 pi over 4. Well, 8 pi over 4 is just 2 pi. This is also known as 0 radians. So 0 radians and 2 pi radians are both going to be right there at 360. Okay, now let's look at the 30 degree ones. So if I have pi over 2, so let's look at pi over 2, and I want to take a third of that. So a third of that is pi over 6. So we know that 30 degrees is pi over 6. So now if I go around for every 30 degrees, I have 1 pi over 6, 2 pi over 6. Wait a minute, that simplifies to pi over 3. You see where this is going. Yes, we have to love fractions. Fractions are your friends. Pi over 3. So 1 pi over 6, 2 pi over 6. This is 3 pi over 6, which we already know is pi over 2. Okay, 4 pi over 6 that I'm going to make you simplify. So 2 pi over 3. And then see here, we have 5 pi over 6. Well, 5 pi over 6, then 6 pi over 6. Well, we already know that one. Then 7 pi over 6. Then 8 pi over 6, which we can simplify. 9 pi over 6, which is already written for us. 10 pi over 6 that we're going to simplify. And then finally, 11 pi over 6. So right there, you know that they come from the non-simplified versions, but you can go ahead and simplify each of those fractions. And these are all of the angles that we need to kind of realize where they are on the unit circle. So I'm not saying you have to memorize where 3 pi over 4 is, but if you know where 1 pi over 4 is, you can go through and say 1 pi over 4, 2 pi over 4, 3 pi over 4, and you can find it that way. All right, we're going to fill out the coordinate points on a different slide here in just a moment. Before we fill out all the points on the unit circle, I do want you to recall your sine, cosine, and tangent, of course. So your sine opposite of our hypotenuse, then cosine, then tangent. These will come into play when we go ahead and look at the points and actually what those mean for the angles. So for now, I have zoomed in on our first quadrant here because what we need to remember is those special triangles play a role because this is a 30-degree triangle if I think about bringing this down here. And remember, the whole reason it's called a unit circle is that the hypotenuse is 1. It has a radius of 1. So right here, if we think about the hypotenuse being 1, half of that is going to be 1/2. And then multiplied by root 3 would be root 3 over 2. So remember, the x value is root 3 over 2, and the y value is 1/2. So this point right here for 30 degrees is root 3 over 2, comma, 1/2. And this is an important point because a lot of the angles on here have essentially the same point, except, they might be positive or negative for the x or y's, depending on what quadrant they're in. So if I come over here in the second quadrant and I reflect, you realize my x's are going to negate, so I can go ahead and do that, but my y's stay positive. And then if I come down here and reflect over the x-axis, my x's still stay negative, my y's now negate. And then over here at like negative 30 degrees or 330, if I negate that point again, I have the x's are positive and the y's are negative. So all of the points that we have just filled out have the reference angle of 30 degrees. In other words, all of these have the same x value and the y value, except the fact of the negative signs and the positive signs, depending on which quadrant they will be in. So if you are looking at the angle of 210 degrees, you realize that's going to have the same values except negative of 30 degrees because 30 degrees is the reference angle. All right, let's go ahead and look at the next one. The next one is a 45-45 triangle with still the hypotenuse being 1. Great. So here then, 1 divided by root 2, after you rationalize it, will be root 2 over 2. So both of those have the same, because remember 1 divided by root 2, you got root 2. So root 2 over 2. Okay, just a reminder. So again, this is in the first quadrant, so it's positive, positive. When I reflect it, I'm going to have the negative 1 over here. And of course, the y is positive. Down here in the third quadrant, they're both going to be negative. And then over here in the fourth quadrant, my x will be positive, but my y will be negative. Again, all of these angles that we just labeled all have the reference angle of 45 degrees. In other words, their x's and y's are pretty much the same, except put them in the right sign depending on which quadrant. All right, and then the last one we're going to look at here is the 60 degrees. And this right here is just kind of the same triangle as 30 degrees, except, the x's and the y's are switched. So right here I have a 1/2, comma, root 3 over 2. So now go through and do all of your reflecting. And magic, they're all filled out. So all the ones in blue right there have the reference angle of 60 degrees. Yay! Okay, last one. We need to look at our multiples of 90 here. So we know that this point, people forget that this is on a coordinate plane. So this point is 0, 0. So the point to the right, 1, 0. The point up at the top, 0, 1. Over here, negative 1, 0. And here, 0, negative 1. So now we filled out all of our x and y values. But how does that help us and what does it mean? Oh, remember when we started talking about the sine is going to be the opposite over the hypotenuse? Oh yeah, if we look back over here at 30 degrees, the opposite is that 1/2 and the hypotenuse is 1. So the sine is the 1/2. So this is sine of 30 degrees. Oh, wait. And then the adjacent over there on the bottom there over 1 is the cosine. So all of these right here, all of the points follow the same suit, where the x value is your cosine and the y value is your sine. The x value is your cosine, the y value is your sine for all of the different angles, okay? And so then if I know that, I can also think about tangent. Tangent's opposite over adjacent. So if I again look at 30 degrees here, and so I can think of it as like 1/2 over root 3 over 2. So in other words, y over x. So my tangent is my y over x, or you can think about tangent as being the sine over cosine, yes? And again, I can put some angles here, make us feel better about that. So sine over cosine. So if you think about tangent in each of these quadrants, tangent here would be positive because it's positive over positive. Tangent here, positive over negative is negative. Tangent here, yeah, negative over negative is going to be a positive. And then here the tangent is negative over positive, which is negative. All right, so like I said, right here, I realized once I already made this, I could not actually add a link in the video, and so I will go ahead and post the links for the blank unit circle and the filled out unit circle in the comments below. Enjoy! Thank you!